Good morning and welcome to this webinar which will introduce CIRIA's new culvert screen and outfall manual. To start, just a few words on how we'll be running the webinar. If you have any problems connecting or hearing, please send us a message via the chat facility. Also, we are recording the event and this will be available early next year. We have over 350 people registered for the event, drawn from a range of different types of organisations, including over 50 from local authorities, over 130 from asset owners, including Environment Agency, Network Rail and Highways England and others, more than 100 consultants, and more than 50 others, including contractors, academic and other research bodies, so a good cross-section. Following this short introduction, there will be two main presentations from the principal authors of the guide. We have planned a Q&A session at the very end of the webinar. However, please submit any questions you may have using the question box throughout the session. Please state if you wish to direct your question to a particular speaker. We'll monitor them as they come in and we'll try to cover as many as we can in the time available, and we aim to close at about 11:15. As most of you know, all CIRIA projects are collaboratively funded. CIRIA would therefore like to thank the funders for supporting this work. Also, while the guide was written by a consortium from JBA and Mott MacDonald, the development of the document involved extensive consultation and peer review, and we would like to extend our thanks also to the project steering group and to the many others who contributed comments on the drafts. And last but certainly not least, the multidisciplinary author team drawn principally from JBA and Mott MacDonald, which included input from those engaged in the prior guide. So about the manual. So why was it an update necessary? Firstly, to learn from recent operational experiences. It also provided an opportunity to bring and link together a number of different CIRIA and Environment Agency guides and manuals. This consolidation would also bring the three documents in sync and make future updating easier. Finally, the timing of the project enabled links to be made with the update of the design manual for roads and bridges. The principal guides on which this manual builds are the CIRIA Culvert Design and Operation Guide 2010, which I'm sure many of you will be familiar with, a supplementary technical note on understanding blockage risks, and the EA Trash and Security Screen Guide. Also, as just mentioned, the Design Manual for Roads and Bridges, DMRB. Previously, the requirements for culverts and outfalls on the strategic roads networks, covering motorways and trunk roads, were specified in DMRB 4.2 HA 107. This document refers to CIRIA Report 168 on the hydraulic design of culverts, with many other requirements specified in HA 107 regarded as being strategic road network specific, which may not apply to non-road network designs. As part of the DMRB modernization program, this approach has been completely revised to draw heavily from the new CIRIA manual, and HA 107 is about to be reissued as CD 529, Design of Outfall and Culvert Details. This approach is to avoid duplication of guidance and to ensure that selected sections of CIRIA 768 become mandatory requirements guidance applicable to the SRN network, whereas other sections may remain as guidance for culverts and outfalls away from the SRN road network. Scope. The guide involved input from across the UK and its coverage is UK-wide, with broad coverage of the legal framework. And it includes both UK and international case studies and of course draws on worldwide experience and research. Also on scope, the manual is aimed at a wide audience, including those involved in planning, design, construction and management of drainage works, as well as planners and other regulators. So that concludes my introduction. So we would now like to hand over to Jeremy, Ben and Amanda Kitchen to undertake the remainder of the presentation. While we hand over the screens to Jeremy and Amanda, brief introduction. Jeremy is chair of JBA Consulting and has over 35 years experience working on the design and construction of culverts and screens. He has been an expert witness in several legal cases in the UK and Ireland related to flooding at culverts and screens. Amanda is a principal engineer at Mott MacDonald with 23 years experience of water engineering, from strategy studies to design and construction. Her professional interests encompass flood risk management, river and canal engineering, with a particular emphasis on hydraulics and heritage. So we can see your screen, Jeremy. So over to you.
Okay, thanks very much, Owen, and good morning, everyone. So, as Owen has already said, the new manual is a merger of 3 existing documents, each of which actually has their own history. So there at the top are the CIRIA culvert design guides. The first one came out in 1997. And then the various iterations of the Environment Agency Trash and Security Screen Guide and DMRB. The new manual is a glorious 471 pages. So it's going to be an exciting Christmas read for you. It's split into 13 chapters. Spread through the document, we have what are called good practice principles, which are little key points, learning points, and not relevant to every asset, but for instance, of those 51, probably only 20 are directly related to screens, for instance. We have 16 case studies in the final appendix to the guide, which go through examples of good practice and past experience of culvert, screen and outfall operation. And there's also a comprehensive set of worked examples relating to the hydraulic methods that are described in the manual. Plus, of course, we have the usual executive summary and comprehensive table of contents and glossary and a set of references. And as the document is in PDF, it's searchable, and you can click on bookmarks to move from one part to another. In terms of other navigation aids, it is a big manual. It's covering a lot of different topics, which may not be of interest to every reader. So we have a roadmap in the start of the manual called "How to Use this Manual" section, and it'll ask you some key questions such as, are you looking at the assessment of need of a culvert? Then go to section 3.2. Are you interested in designing a new culvert? Then go to these sections and so forth. And we also have tables of typical interest or need in the manual. So here's just an example. If you're an asset manager and you wanted to know the management essentials of culverts and screens and outfalls, there's a summary of the topics we think that are most relevant and where to find them in the manual. So hopefully that will help with navigation through what is quite a large document. So let's just have a look at some numbers for culverts. It wasn't part of the research associated with this to come up with definitive numbers, but nevertheless, we did gather some information. For instance, the Environment Agency is responsible for over 10,000 culverts in England. On the trunk roads networks of the UK, there's at least 100,000 plus culverts. The canal network in England, 2,500, and the Great Britain Railway network, 22,000. So we're easily well in excess of 200,000 existing culverts on the major infrastructure. In terms of screens, the Environment Agency is responsible for 2,500 in England. The road network has approximately 30,000 of them. The railway is about 12,000, and so we must have at least 50,000 in the UK, and presumably considerably more. There are some key themes throughout the manual, and that is that the manual takes a systems approach to the design and operation of these assets, so that you look at the particular culvert or screen that you're analysing or considering as part of the wider river system. It also takes a risk-based approach, not only from a flood risk viewpoint, but also from a health and safety and an economic viewpoint. And it's very much focused on sustainable assets and whole life asset management. And the diagram on the right shows the considerations that you would need, particularly to have a whole life asset management approach, and that is that you need to consider hydrology and hydraulics, including climate change, whole life cost and carbon, the environment and geomorphology, the structural performance of the asset, how it will convey debris or cope with debris, how it will be constructed and maintained, and of course key is safety. So in terms of the need for a culvert, the manual is very explicit in saying that we should be avoiding culverts if there are viable alternatives, but accepts there will be some cases where the culvert is the best solution, and that would be for carrying infrastructure over a watercourse, where the other alternatives, such as relocating that infrastructure somewhere else, diverting the watercourse, say combining river channels, so instead of having 3 culvert openings, you can have 1, using a bridge or using a ford as another means of getting the infrastructure over the river. It also recognises that culverts can have some significant disadvantages in terms of potential adverse effects on aquatic life and other species and fauna, impact on natural channel processes, can increase flood risk if designed inappropriately, introduce a confined space hazard, and of course has a maintenance requirement and could impede groundwater. In terms of a screen, the primary purposes of screens are to reduce flood risk or to reduce safety hazard or to provide security. They can have substantial disadvantages. They can actually increase flood risk if not designed and operated properly. They introduce a new entrapment risk, that is entrapment against the screen. There's a maintenance need and cost associated with them. And the manual describes several alternatives to a screen. First and foremost is to remove the culvert or outfall if possible, and therefore you don't need a screen. Keeping the culvert outfall barrel short and large, which will reduce the potential flood risk and the safety hazards, and therefore may not need a screen for either of those. Having an increased inspection and maintenance regime, looking at other catchment management measures to reduce debris loads, and looking at eliminating and reducing entrapment hazards within the culvert, such as removal of services and so forth. And then also to provide a bypass so that if the culvert barrel did get blocked or partially blocked, water could find its way around without causing excessive flooding. Then finally, in terms of outfalls, the need for an outfall structure is to restrain the pipe or the earthworks of the carriageway or the railway. It's there to control the exit flow and to dissipate the energy. It allows easy entry for maintenance, such as jetting and cleaning and inspection. You can also add a non-return valve or security screen if needed, and it does allow flow monitoring and water quality modelling. But there are alternatives to a formal structure, such as providing soakaways and swales. Get rid of the pipe, so therefore the pipe doesn't need an outlet, and also the use of bioengineering techniques. One thing that's completely new in the manual is the initial need assessment. This is both initial need assessment for a screen for both security and debris management purposes. There's a separate assessment method for each one. It's meant to be just an initial assessment method. It's been designed that it could be completed in probably less than an hour. It's a 6-step process, and there's a template form to fill in, which is also going to be available as a spreadsheet from the CIRIA website. And on the right, just shows you the basic process for this initial need assessment. So first of all, you gather information on the asset, the culvert where you're proposing a screen. You score factors relating to the culvert. You sum those scores from each factor, apply a decision rule, then finally do a sense check, and then confirm the decision on whether this initial assessment indicates you need a screen or not. Let's look at the factors, and here they're listed for both the security screen and the debris screen assessment. A lot of these were used in the existing EA Trust Screen Security Guide, but there's some new ones. These have been derived by looking at those that are most significant in terms of leading to either a health and safety risk or a blockage risk that a screen would help mitigate. And for security screen, that is the rate of rise of the water level, the length of the culvert, the flow conditions in the culvert barrel, the risk of being trapped inside, and then how accessible the culvert is. Each of these factors, by the way, have a different weighting, so that is a difference from the existing Environment Agency Trust Screen and Security Guide, where the factors there all had equal weighting. And then for debris screen assessment, it's looking at the flow approach conditions to the culvert size, its hydraulic performance, the potential for debris generation upstream, the potential for debris to actually be trapped in the culvert, and then any other features. So to get a score for each of these factors, you basically talk through several questions that you need to answer. And there's only 3 answers, yes, no, or not applicable. This is just taking an example from the security screen assessment and looking at factor D, which is looking at the possibility of being trapped inside the culvert. So asking you questions about features of the culvert that should be readily known to you, that are generally good indicators of a risk. And you can see here in filling this in, we've said that the culvert barrel has significant bends of more than 20 degrees. So that's got a potential score of 5. We've also said the barrel cross-section area changes. It's got a score of 12, and it's got some service crossings, which is 15. And what you do is you say yes or no to all those that apply, and then you take the maximum score to be carried forward. They're not cumulated. One thing that's intended with these forms is that it also creates automatically an audit trail for you. So for instance, just looking at this screen, even though the score is 15, and that is predicated on the service crossings, of course you are keeping a record that there were other features of the culvert that were of concern in terms of entrapment hazard. Once you've gone through that for each of the factors, you sum the maximum scores. That will come somewhere between 0 and 100. And then depending on what that score is, you go to this decision rule to decide what to do next. If the score is between 0 and 40, a screen is not required. If it's between 41 and 65, a screen is probably not required. And it's worth considering other measures to deal with residual risk. And if it's above 66, a screen is likely to be required. There is one final stage in this process, and that is just to do a sense check. We've tried to keep the spreadsheet and the form as simple as possible, and deliberately something that can be completed in less than an hour, using some very basic information. Yeah, every culvert is unique. Something might get missed, so these are very much questions to just trap if we've got a false answer. So for instance, this is just an example. You go through these sense checks, and if you say false to any of them, then you need to reconsider the score that you've got. We've tested the initial need assessments for both security and debris screens and over 200 culverts and screens. But obviously it'd be great to get feedback as the new manual is more widely used. The assessment method has inbuilt the capability for it to be updated. For instance, you can add additional questions to those factors and change some of the weightings if you wish to. In doing the testing, we have found that generally fewer culverts are found to need a screen, either as a debris screen or a security screen, than the previous methods. And that also squares with the operational evidence and experience, which has suggested that some of the screens that have been provided in the past are no longer actually required. So that I'll hand you over to Amanda, who will talk you through the principal changes to the guide.
Thanks very much, Jeremy, and good morning, everybody. So the new manual covers a range of changes. It's been updated to reflect legal and policy changes since the 2010 publication, and also lessons that have been learnt in flood events and from operational practice in that time. So within the legal and policy framework, some of the changes that we've seen have been the Flood and Water Management Act, which introduces lead local flood authorities and also defines a culvert for the first time. And it requires the lead local flood authorities to maintain a register of structures which could affect flood risks, such as culverts. The Flood Risk Management Scotland Act imposes a duty to map and assess structures with the potential to affect flood risk, but it goes a little bit further in promoting sustainable flood risk management and a move away from structures such as culverts and towards natural channels. We also saw the introduction of the environmental permitting regulations, which introduce environmental permits for works on main rivers, which replaces the flood defence consents in England and Wales. And Wales also introduced requirements for sustainable drainage for new developments. The WFD regulations transpose the EU Water Framework Directive into UK law and uncover environmental objectives for water bodies. And finally, the construction design and management regulations replace the 2007 regulations and introduce the principal designer. Approaches to safety have advanced as a result of new law and operational experience, and we have much greater awareness of the hazards associated with manual handling of debris and working on screens in high flow conditions. So we have a new safety chapter which emphasises carrying out risk assessment to compare the culvert or the screen with the open channel alternative, and a move towards retaining open channels wherever possible, constructing culverts and screens only when there's no viable alternative, and removing or daylighting redundant structures where possible. But we acknowledge that culverts, screens and outfalls can't be avoided in all instances, so if they have to be constructed or retained, then we should try and avoid or minimise manual handling and use mechanical methods instead. We should aim to work during low flow conditions rather than high flow conditions if possible. And if work during high flow conditions is unavoidable, we should provide safe access for vehicles and pedestrians. So we want to see a move away from the situation that we can see in the photograph, where we've got operatives standing on a screen with probably quite deep water nearby. It looks like they're standing on the debris, and there's a risk that the debris could move and they could end up falling into the water. It's also important to carry out planning and pre-inspection work to identify hazards and special access requirements, so that inspection and maintenance can be carried out safely and efficiently. And there was a case study recently where a culvert was repeatedly omitted from full inspection due to lack of information on the confined space hazards, and as a result the structural defects weren't picked up, and that eventually led to collapse of the culvert. Natural processes are integral to the sustainable design of culverts, screens and outfalls, and the manual covers the assessment of short and long-term direct and indirect impacts of a project or programme on its receiving environment. And the mitigation hierarchy advocates measures that avoid, minimise or reduce impacts in preference to remedial measures. So new culverts should accommodate fish, eel and mammal passage, sediment transport and morphology by design, ideally. The fish passage guidance is based on the Environment Agency Fish Pass Manual, which is now published by the Institute of Fisheries Management. And it also discusses the potential behavioural obstacle presented by a dark culvert, and concludes that the installation of light wells lacks compelling evidence. So it suggests providing wider wing walls, pools or resting areas at the transition from the natural channel to the culvert to ensure that fish aren't discouraged. For mammal passage, benching or a separate dry culvert are preferable to a raised shelf, which is undesirable and should be retrofitted as a last resort. It's also important to understand the river when assessing the potential effects of a culvert, screen or outfall, whether it's being constructed, modified or removed, and also the impacts of blockage. So we need to think about the river type, the catchment history, its flashiness, sediment supply, the composition of that sediment and the dominant sediment processes. And without this knowledge, an unintended channel response could occur. So a culvert could act as an in-channel barrier and disrupt sediment continuity, causing sediment to become trapped upstream, or sediment starvation downstream of a culvert, or increased velocities could lead to scour and undermining, as we can see on the right. And the manual gives design principles for new culverts and outfalls. So locating a structure where there's a low risk of outflanking, keeping a culvert length to the minimum, avoiding large changes in velocity which could lead to turbulence and scour, and minimising the need for future sediment removal, which has an added benefit of keeping the whole life cost down. The hydrology chapter has been updated, and that includes relevant new research and methods that have been developed since 2010. It includes the latest guidance from UK regulators and climate change guidance. So it includes new methods of flood estimation, including RefH2 for design hydrograph estimation, driven by the FEH 13 rainfall frequency statistics, and the methods for small catchments draw on research, such as applying FEH at a downstream location and scaling down on catchment area. It also includes reference to online data sources, such as the FEH web service, and it comments on sources of uncertainty and ways of reducing this, such as checking the catchment boundary and short-term flow surveys. The main guidance on hydraulic assessment remains unchanged from the Culvert Design and Operation Guide, although performance requirements are expanded to include blockage, fish, eel and mammal passage and outfalls. The hydraulic assessment methods for culverts have been streamlined and define 3 levels of assessment, from simple to detailed, to allow selection of a proportionate approach. The methods for screens are simplified and expanded to include free and submerged orifice flow and the choking of screens. Super elevation at bends is added, and methods for assessing scour and assessment sedimentation are expanded. We've renamed overtopping as overflowing for consistency with the ICE floods and reservoir safety. And the manual also defines permanent blockage and variable blockage in line with the structural Eurocodes. The hydraulic modelling guidance no longer cites specific software packages due to the fast pace of the market, but guidance on modelling complex scenarios has been expanded to include blockage and screens. The concept of freeboard has been redefined in the context of culverts and outfalls. So freeboard is defined as the vertical gap or allowance between the design water level and the soffit of the culvert or outfall, and it's the sum of the residual uncertainty allowance and the headroom or air draft, which is the minimum space between the design water surface and the soffit of the culvert, required to allow the passage of floating debris through the culvert without getting snagged, and also to provide air to anyone swept into the culvert. And then the sediment allowance is the vertical depth or allowance above the culvert invert or outfall invert to allow for possible sedimentation. And the freeboard and sedimentation allowances from the 3 individual source guides have been combined and consolidated. The manual presents new guidance on the blockage of culverts, drawing on research for the Environment Agency Blockage Management Guide, which was launched earlier this week. And recommendations are given for narrow culverts, where the opening is narrower than the low flow channel or the typical floating debris for the watercourse. It also gives guidance for culverts with a low opening, where the height is less than the design flow depth or the typical debris size, or has a freeboard of less than 0.3 metres, and also culverts with a central pier in the main flow. And data from historical flood events has shown that long debris can bridge an opening if the span or the diagonal is less than 6 metres, or alternatively, if it's less than the design log length, that is the lesser of the upstream channel width and the maximum length of a sturdy log that can bridge the gap without breaking. Screens are unlikely to remain clean during flood conditions, and man-made debris, vegetation and sediment can accumulate between maintenance. Blockage can have a number of impacts. It can reduce the cross-sectional area available for flow. It can restrict the flow through a screen and reduce the pass-forward flow. It can increase upstream water levels and the afflux due to the screen, and it can also increase the storage of water in the channel or floodplain upstream. So it's important that we assess this. We've adopted Eurocode terminology to describe the 2 types of blockage. So we describe permanent blockage, which is due to permanent fixtures such as the screen bars, and variable blockage due to temporary accumulations such as sediment or floating debris that may occur between maintenance or cleaning. A screen should perform adequately for the design flow, even if it experiences significant blockage. So hydraulic assessment and design should assess the impact of blockage on hydraulic performance and flood risk. The nature of the variable blockage affects the flow type and the method of hydraulic assessment. Top left, we can see a clean screen with permanent blockage due to the screen bars only. You're very unlikely to see this during flood conditions. An alternative scenario is blinding or pseudo-weir blockage, which we've got bottom left. This occurs when impermeable debris accumulates on the lower part of the screen and acts like a weir, so it reduces the flow area and increases the upstream water levels. Permeable blockage, which we've got illustrated top right, occurs when permeable debris accumulates across the full height of the screen. The blockage is likely to be random, as you can see, but it can be schematized by a solid blockage over the full height of the screen, but part of the width, as we've got bottom right. We can see orifice flow when the screen opening area is less than the culvert inlet area, and submerged flow at the screen is combined with free flow in the culvert. If you're not sure which kind of blockage and flow type you're going to have at a screen, then it's sensible to assess both blinding and permeable blockage and see which has the worst impact on flows and water levels. The effective area of a screen is key to its hydraulic performance, and this is the net opening area that's available to carry flow and excludes areas that are above the maximum allowable water level. It excludes working platforms and any areas that are permanently obstructed, for example, due to the supporting bars. The effective area should be at least 3 or 4 times the culvert or outfall area, and as large as reasonably practicable. So we're looking for an area of at least 4 times the culvert area for security screens, which have a 0.15 metre centre-to-centre bar spacing, and a ratio of 3 or more for debris screens, which have a wider bar spacing. And we would expect a larger ratio, a larger screen size, if the debris load is likely to be heavy, or if the screen could block before operatives are able to mobilise and remove material. But screen sizing is uncertain due to limited blockage data and factors such as land use and climate change. And it's also important to be aware that an undersized culvert may not form a good basis for the design of a screen. And screen sizing and design is iterative, as blockage and hydraulic performance are influenced by the bar size, the angle of the screen to the horizontal, the number of stages, and the maximum safe water level. The manual gives updated guidance on screen bar spacing, which influences the likelihood of blockage and should be the widest possible that it can be to achieve the design objective. So we now recommend a modular approach to bar spacing with bars at multiples of 150 millimetres. Bar spacing can then be increased or decreased by adding or removing bars, for example, in response to land use changes during the life of the screen. So a security screen can be converted to a debris screen by removing every second or third bar, subject to a structural loading check. And a debris screen can be converted to a security screen by adding more bars, for example, if development occurs nearby and safety risks increase. For coarse screens, the bar or pole spacing should be between 1/4 of the downstream opening width and 3 metres, tailored to the debris that might need to be trapped. And research has shown that a screen with a bar spacing that is half the debris length will trap about half of the debris, with more debris being trapped for a smaller spacing. The manual gives updated guidance on screen design, in particular access. A screen should have safe access for debris removal during low and flood flow conditions, and both day and night, and it should allow a timely response to blockage. It's not always possible if a working platform becomes submerged, and we shouldn't expect operatives to work from a submerged working platform. On the left, we've got a screen with a lot of debris during high water levels. The working platform has been submerged and clearance isn't possible. On the right, we've got a two-stage screen, which can be cleaned from either of the two working platforms. The manual brings together guidance on screen design, and some good practice design features include vehicle access, parking, storage for materials, and a clear route to the screen that's free from trip hazards or obstacles. The preference is for steps or a ramp to each level of the screen and the watercourse, and avoiding using ladders unless space is very restricted. We should also look to provide fencing or handrails to reduce the risk of falling into the channel, with gates and removable handrails to allow access to clean different areas of the screen. And we should also provide access to the culvert for periodic inspection via an access hatch in the working platform. As we've already discussed, there's greater recognition of the safety risks involved in manual screen clearing. So screens should be cleaned by methods other than manual raking if possible. Preferred design features include two-stage screens that allow easier raking, a wider bar spacing that traps less debris if that's compatible with the design objectives, and removable rails that allow access for the removal of large items. What we don't want to see are things like horizontal bracing members, which can impair raking, and large gaps between the screen and head wall, which can create a foot entrapment hazard. The advice on the geometry of a screen designed for manual raking remains unchanged, so we're still looking at a vertical distance between working platforms of 1.2 metres or less, screen length of 1.5 metres or less, and screen panels preferably sloping at 45 degrees to the horizontal, but no more than 60 degrees. Screens that have been designed for mechanical raking may have a longer screen, but that should be no longer than 3 metres to avoid the need for bringing very heavy plant to site. The manual reflects changes in asset management policy and standards, and it draws on lessons from past flooding. So it has been updated to reflect ISO 55000, the new international standard on asset management, as well as best practice in highway asset management and network rail policy on asset management. The asset management processes and systems should question whether an asset is still needed, and asset management should be risk-based and proportionate. So, for example, the level of detail in hydraulic assessment should be based on the risks, the land use, and the sensitivity to flooding. The manual provides some decision support tools that can be used, such as risk management matrices, and it also covers operational plans for structures that need regular maintenance. These should cover site-specific issues So what to do, what not to do, emergency procedures. And the manual also gives typical inspection frequencies for culverts and screens. Remote monitoring can inform a prioritised incident response and allow operational staff to focus on assets where there's blockage. This can also reduce the environmental impact of travelling to a screen and free up staff to do other work. So water level monitoring and visual monitoring are quite useful. Water level monitoring can be linked to telemetry to provide an indication of blockage with or without automated alarms. A high upstream water level or a high water level difference across a screen or culvert indicates a high degree of blockage. Visual monitoring using CCTV or webcams can be used for screens or culverts, and it can also be helpful to paint the lower portion of a screen to indicate the trigger level for debris removal, as we can see on the figure here. It's important to record the degree of blockage and the type and quantity of debris that collects on screens to build up a picture of the degree of blockage, the probability of blockage, and the potential impacts it can have. So ideally, you should take photographs at every inspection and record your data for future reference. The manual continues to reinforce the aim of removing existing structures where possible, but where a structure must be retained and needs to be repaired, it provides a decision support flowchart to help with the selection of repair methods. And this considers whether the culvert has fully or partially collapsed, the access, length of the culvert and its depth below ground, whether the culvert has sufficient hydraulic capacity, and whether measures such as patch repairs or pipe bursting are suitable. The guidance on culvert lining has also been updated with tables summarising the suitability of each method for different conditions such as culvert length, lining thickness, whether it can accommodate bends or changes in cross-section. So that's a brief overview of the principal changes to the manual. I'll now hand over to Jeremy for some case studies.
Okay, thank you, Amanda. I'll just quickly go through three simple case studies, starting with one on a culvert. The new manual doesn't actually have any standard details for either culverts, screens or outfalls. And that's for the simple reason that as is advocating a systems and risk-based approach, there is no sort of universal solution to a wide range of problems. Shown here is a culvert, and this is flowing at close to its design flood. We're looking at the inlet here, and there's much that about this culvert that complies with the new manual. So the first thing that you can see is that there is an air draft or freeboard above the water surface, which will allow floating debris to pass into the culvert, and also an air gap to breathe if someone was washed in. Also at the inlet, there's an acceleration of flow into the inlet, and again that helps to keep floating debris in movement into the culvert. Although you can't tell directly from this photograph, this culvert is short, it's only the width of the road, it is straight, it doesn't change section. And finally, in terms of the high flow operating performance, is that above the culvert, the road level has been lowered to provide an emergency overflow route. So if this culvert did block, or if the design flood was exceeded, flow would actually flow over the road in extremis. And in this particular location, that's important because if the road was higher and didn't provide the overflow, in fact, the first phase to flood would be a large housing estate, industrial estate immediately upstream. In terms of low flow, although you can't see it in this photograph, this culvert has been designed to provide easy passage to fish and mammals, and to keep a natural bed material through its invert to help with that. Moving on to screens, and here I'm just going to provide an example of a course screen. But just before I talk you through this case study, just to summarise a couple of the key things about screens. First of all, the manual makes it clear that screens are a poor compromise. So screens do not provide a magic wand or a complete solution to a problem of security or debris management. If you want complete reassurance, then the culvert either needs to be removed or adapted to remove that risk. Also, that if you're going to have a screen, whether it's a security screen or a debris screen, it has to be designed as a debris screen, because a security screen would still act as a debris screen once constructed. And thirdly, is also look at core screens as an alternative to a full face inlet screen, or perhaps combined with an inlet screen. Here's an example from the north of England, and here we've got the river. There's a problem with debris accumulation downstream that can exacerbate a flood risk. So here, core screen has been located at a suitable point upstream, there on the left, circled as tree poles. And this is what they look like in practice. As Amanda said, these are about 3 metre spacing. They're designed to trap out 50% of the debris, but certainly the very big debris. And if I can get the technology to work, I'll just show you a time-lapse video of this particular core screen performing during a actual high-level flow event. I would emphasize this actually isn't a flood. Certainly didn't cause any flooding. This is, I mean, the poles have only been there for 3 years. It's one of the high flow events since then. And the time-lapse video is over a period of nearly 2 days. So here you've seen that the debris accumulating against the screen. And now you'll then see the operation to remove the debris. Now, core screens generally are not designed for removal of debris during a high flow event. They need to be designed though for removal of the debris as easily as possible once the water levels have dropped. So you can see here access has been made through a concrete ramp and a working area to get into the channel. Okay, I'll stop that there. Then finally, in terms of outfalls, here's just an example of use of softer materials for the outfall from a drainage system. So the actual head wall is there in the top right as part of a masonry structure. And then it's going into a small retention basin and swale for further attenuation and also to settle out silt and sediment. And it's all been incorporated into the landscaping of this particular development. So moving on now to summary. So the new manual is an update to 3 existing guides, and I guess from today those existing guides are now superseded. And we should start using the new manual, and it's available for free download from the CIRIA website. It is complementary to the Environment Agency's blockage management guide that was launched earlier this week. And as well as the actual guide itself, there are those spreadsheet forms to help you undertake the need assessment for screens, and there's also design checklists for a culvert, a screen and an outfall. What are the possible impacts of the new manual? Well, it's a little bit early to be sure, but hopefully it'll emphasise the need that we should be having fewer culverts, certainly fewer newer culverts, and where we do have them, there's got to be a considered need for them, and that they'll be shorter. Also, they will have fewer, better designed and easy to maintain screens and outfalls. And together this will provide lower carbon solutions for infrastructure development. And in terms of, if we wanted a perfect screen or a culvert that was fully sustainable, had least maintenance cost and least impact, then these pictures illustrate what they should look like. I'm afraid a culvert, a screen, an outfall inevitably is a compromise, but we've got to make sure it's an appropriate compromise. In terms of finding out more, it's all there in the manual. You can download it either as a low resolution version or a high resolution version. The high resolution version is quite big, but obviously the diagrams are clearer in that one. And allied with the manual, from the new year, CIRIA will be launching a new series of training courses based on the manual. There'll be 2-day courses. The first day dealing with what's new in the new manual and how to use it to assess need for these structures and asset management in general. And then day 2, concentrating on the design of them. So that's it for the moment. So we'll take questions now, if that's okay. How this is going? I'll probably let Owen take the line now.
Yes. Thank you very much, Jeremy, and thank you very much, Amanda. Yes, we have a few questions which I will go through, but just a reminder to others on the call, if you would like to submit some questions, then please do so. The first one is there any guidance on the design of course screens? So can you elaborate a little bit more on the extent of guidance on the design of course screens?
There is some guidance on that. So he gives some guidance on the spacing of course screens. I don't think it covers the structural design. The guidance overall doesn't deal with the structural design of culverts and screens. It's more about the hydraulics and the blockage and the environmental aspects of it.
Okay, thank you. Another screen related question. Does the screen assessment also include pumping station inlets where they are normally standard?
No, the need assessment actually explicitly excludes that. I mean, there is mention of pumping station inlets in the new manual, but we do make the point that the design of those are a very specific exercise, and it has to be part of the pump size selection and the M&E design. Because, for instance, is the hydraulic losses through the bars will be a material part of assessing pump performance. So you've got to know that. So
yeah, and they tend to be quite steep and mechanically raked, and they have a much finer bar spacing.
Okay, another question. This related to the spreadsheet table D, Jeremy, that you showed. The questioner said the maximum score was shown as 40. So why were you only using a maximum of 15 in this example?
Right, yes, sorry, the slide is perhaps unintentionally misleading there. Just to make it readable, I'd actually chopped half of that table off. So when you actually read it in the guide, there's lots of other questions underneath that which actually go to the maximum of 40.
Okay, thank you. Was the document reviewed by CIPA, and will this now modify CIPA policy on culverts?
I'm not sure that it has been reviewed by CIPA. We had in the Environment Agency, we had Natural Resources Wales and DOE Northern Ireland on the project steering group, and also Transport Scotland, but CIPA weren't involved, to my knowledge.
So that remains to be seen then on that one. We'll follow that one up. Have any more come in recently? This one. For assessments, are there spans above which the culverts are considered safe and thus don't need assessment?
In terms of blockage, there has been research done in Australia. There was a very large number of culverts examined after a major flood event, and they looked at the culverts that are blocked and the span of those culverts. And what they found was that the culverts with a span of less than 6 meters or less, were more prone to blockage, and those with a span greater than 6 meters were unlikely to block. And the reason for that is that the blockage or the bridging of a large opening is very much dependent on whether, not just whether something can span across it, but also whether it can resist the hydraulic action. So even if a large tree trunk spanned a culvert that was wider than 6 meters, the hydraulic forces on that tree trunk would probably cause it to break, so therefore it wouldn't stay there for very long. So 6 meters does seem to be the limiting span.
Okay, thank you. Is there guidance on the sizing and siting of flood relief arches?
There's no specific guidance on that, although when you follow through the hydraulic analysis sections of the manual, you can take those into account. So, because obviously there you'll be introducing additional flow area and additional barrels, and then the analysis will show the hopefully the beneficial impact that will have on flood levels.
Yeah, I think that the key things to be thinking about are avoiding increasing flood risk, but also making sure that you don't have too wide a flow area at low flow conditions. If you do have a very wide low flow channel, then the flow can slow down and result in sedimentation, which is obviously, too much sedimentation is undesirable. So I think those are the things that you would need to think about.
Okay, thank you. Next question was, there's a mention that bar spacing as 150 millimeters. Is this between centres, or is it the gap between the bars, i.e. ignoring bar width? Perhaps this is explained in the manual?
Yes, that's centre to centre. So for a security screen, then you would expect normally to have 140 millimeters clear spacing with 10 millimeter bars. So the multiples, the 150, the 300, 450, and so on would be centre to centre spacings.
Okay, next one relates to the case studies. Was case study 1 Ruthin in North Wales? If so, a screen had previously fitted and identified as a contributory factor to past flooding, and since then it has been removed. So probably a comment rather than a question, but I don't know whether you want to comment on that, Jeremy?
Well, useful comment. In fact, that case study partly came from the previous Culvert manual. Yeah, so it might well be that that's describing an historical condition.
Okay, the next one's a long question, so bear with me as I try to read it. Note on the environmental impacts were mentioned in terms of Water Frameworks Directive. However, when permitting works under the environmental permitting regs, the Environment Agency takes into account all impacts on the environment, flora and fauna, and not just WFD status criteria. Any culverts should be designed out, if possible, at the start of the design and site layout, and there will be a need to ensure that costs of land for mitigation and compensation is included in costs, especially if net gain becomes mandatory, as culverts will be a loss in any net gain calculation. So again, a comment, I guess, rather than a question, but if I to comment on that.
I don't think there's much we can add to that.
No.
I mean, we do mention environmental net gain and biodiversity net gain in the manual, and the section on natural processes does go into great length about the considerations and goes well beyond just a WFD assessment.
Okay, another question related to some of the diagrams. The long section showed a freeboard, but this didn't seem to include an air draft for the culverts.
Okay, so the freeboard is the sum total of the residual uncertainty allowance and the air draft. So your residual uncertainty allowance was introduced a couple of years ago to replace the old concept of freeboard, and that accounts for the uncertainty you've got in, say, hydrology or your hydraulic analysis. And what we're suggesting is that you should take your residual uncertainty allowance and add a bit more to make sure that you've got sufficient space. Even if that residual uncertainty allowance came to being, you've still got enough airspace or air draft for any floating debris to pass through the culvert without getting snagged.
Okay, thank you. Is there advice or guidance on erosion scour control at inlet and outlet of a culvert?
We do provide guidance on the assessment of scour. The guidance is fairly limited because there is very comprehensive guidance in the manual on scour at bridges and other hydraulic structures, which was published by CIRIA in 2015. But it does give advice on working out whether scour is likely to be a problem. It gives some equations on the assessment of scour and the provision of scour protection, but it does, rather than reproduce the scour manual, it signposts it for the detail. Okay,
thank you. Does the guidance include siphon chambers within existing culverts?
The hydraulic assessment guidance gives advice on assessing the losses due to bends, and those can be applied equally to siphon culverts or drop culverts as they can to normal culverts with horizontal bends in. But it doesn't discuss the design of siphons specifically. Obviously, those are undesirable because they tend to be sitting full of water all the time, and you've got quite a risk of sediment dropping out and blocking the culvert. And then there's the associated safety risks. But yes, the hydraulic assessment guidance does give you the means to assess the losses through a siphon.
Okay, there are a number of questions. Sorry, Jeremy, did you want to add anything?
No, that's fine by me.
There are lots of questions coming in now on the specific aspects and whether they are in the contents list or not. But there are also some questions that are more technical, so I'll focus on those first. You anticipate the daylighting of culverts being a viable option in urban areas as opposed to culvert renovation?
I think it all depends on the circumstances. It depends on the function of that culvert and what the land use is and whether that culvert continues to be needed. I think there are cases where it could happen. There was an article on Radio 4 recently where somebody was talking about redevelopment where the river had been opened up, it had been deculverted or daylighted and made a positive feature for the adjacent properties, and that was seen as a good thing. So I think with enlightened clients and greater awareness of the attractiveness of water, then I think there is scope for that to happen.
Okay, thank you. Next question. How does the guidance account for owners' ability to maintain any skew factors for private screen culvert owners?
Could you just repeat the question again, Owen?
Yeah. How does the guidance account for owners' ability to maintain any skew factors for private screen culvert owners?
Okay. Well, the manual obviously covers all the the duties, the statutory duties in law, occupiers liability and so forth related to a culvert and a screen. It also goes into a lot of detail about what is needed to make the screen and the culvert maintainable, and makes an absolutely key point that if you can't maintain particularly a screen, then there's not really much point having it. In terms of an explicit difference between a privately owned screen or culvert and a publicly owned one, it doesn't make a difference there, but then I couldn't see how the guidance would be different anyway, unless I misunderstood the question.
Okay. Is there a legal view on retrofitting timescales?
There's nothing in the manual on timescales, and I'm sure you need to get an expert legal opinion on this. I know that in various workshops that we've been involved with in developing the manual, questions are being asked on, for instance, do we have to start adopting this manual right now? Well, obviously it is published now, so we should be using it for new work. What kind of timescale should we then reassessing existing structures against the manual? Again, I'm probably stretching my legal knowledge beyond where I should, but certainly, I mean, I think it'd be unreasonable to expect any authority to reassess existing structures in the next year. But certainly, in the next few years, reassessment, probably would be a good thing to do. Now, that doesn't necessarily mean to say that actually taking action if those assessments identify inadequacies or scope of further improvements, that would be on a different timescale again.
Yeah, I think it's important to note that this is good practice guidance. It's not a standard, so it's not mandatory. It's just a good idea to follow it. So I don't see that anybody would have to bend over backwards to rush out and reassess something, but in the natural course of events as part of their asset management process, then adapt to the new manual.
Okay. Is there any consideration of energy dissipation within the culvert and at the exit?
It's something that the hydraulic assessment chapter touches on, but we signpost some very good guidance by the Federal Highway Administration on which is specifically tailored to energy dissipation at culverts and outfalls. So rather than reproducing the guidance, we touch on the subject and then signpost.
Does the guidance provide best practice for recording debris to inform the assessment, e.g. frequency and debris type?
One of the case studies gives an example of where an operating authority has a system for recording that information. The manual has a good practice principle that monitoring of particularly screens is good practice, and that records should be kept and a full audit trail established. And the guide also uses information that was from the Environmental Research Consortium work on debris at culvert screens using data from Belfast. So there's a category there of how you categorise debris. So for instance, there's a small floating debris, large woody debris. So
yeah, to add to that, I would also refer people to the blockage management guide, which was published by the Environment Agency earlier this week, and that includes an appendix with more detailed guidance on the sort of information that should be recorded, the frequency, and how to log it.
Okay, thank you. Are there any liability issues of removing existing safety screens based on this guidance if an accident subsequently occurs?
Well, there's no ready answer to that. I mean, it would depend very much on the circumstances of the culvert and the screen. I mean, obviously, you wouldn't be removing it unless, in using the new manual, that had indicated that it doesn't increase risk. So, therefore, one would hope very much that there isn't any increased liability. So no, I think to get off the fence, I think if you use the manual fully and as intended, and the conclusion is to remove a screen, and that is fully documented. I think you've got a rational analysis there, backed up by research that could defend any subsequent claim about having removed the screen.
Okay, final question. Again, it's quite a long one, so I'll try and read it carefully. Despite environmental issues caused by culverts, many culverts are continued to be justified due to their perceived lower cost. In Wales, we have had a number of whole life costings undertaken on large infrastructure projects where clear span bridges were found to be cheaper than culverts when looking at whole life costs. Does this guidance look into this financial element or provide case studies to support this particular point?
The guide in the asset management section does include the principles of whole life costing, but no, it doesn't actually provide a case study or an example comparing, a culvert against a bridge option. But obviously, a bridge is a suitable alternative to a culvert in a lot of cases, and particularly if it's lower cost as well and lower carbon, then that would be the right decision to make.
Okay, we're running out of time, so that was the last question. So thank you very much to Jeremy and Amanda for both an informative presentation and also for handling the questions and answering them helpfully. Just a couple of things by means of closing. As Jeremy showed on his slides, the document and the spreadsheets are available from the CIRIA website, ciria.org/culverts. That'll take you to a page where you can download the guides, and also there will be information there about the forthcoming training, and we hope to announce some dates early in January. So thank you to the delegates for taking part. Thank you again, Jeremy and Amanda, and I'd now like to close the webinar. Thank you.